Long before the invention of writing, early humans were forced to invent foundational mathematics simply to survive a brutal world. This is ethnomathematics, the practice of using abstract shapes and measurements to solve the practical problems of the prehistoric world. Artifacts like the Ishango bone, dated to 20,000 years ago, preserve groupings of carved notches that suggest an early understanding of tallying and prime numbers. Early hunters also expressed a fascination with abstract geometry, painting deliberate patterns like red dots and nested curves alongside the animals on cave walls. Geometry emerged as a functional cognitive response to a chaotic, unpredictable environment. To predict seasonal migrations, humans had to turn the sky into a reliable clock by measuring the angles of the sun and stars relative to the horizon. Later, the shift from wandering to building permanent shelters required an understanding of verticality to prevent structural collapse. Builders achieved this by hanging a stone on a string, a plumb line, to establish a true right angle relative to the ground. These abstract concepts of angles and verticality provided the physical order needed to master the environment. Humans observed efficient shapes in nature, like the crescent moon or the parallel lines of tall grass, and sought to replicate those efficiencies. In flint mapping, striking a stone at highly specific points allows early toolmakers to control a conchoidal fracture. This is a type of breakage that results in smooth, curved surfaces. The result was the intentional creation of an isosceles triangle, a tool with a sharp, piercing apex and two balanced cutting edges. By controlling these specific angles, early toolmakers transformed raw stone into precise instruments designed for repeatable mechanical tasks. Societies eventually applied these principles to a massive scale, organizing ritual spaces into mathematically precise circular enclosures. They used the azimuth, the horizontal angle of a celestial object, to align these structures with specific points on the horizon. At Newgrange in Ireland, builders engineered the entrance at a strict angle so that sunlight reaches the inner chamber only during the winter solstice. These massive stone circles also utilized right angles derived from the North Star to align with the four cardinal directions. These massive monuments functioned as ancient analog computers, translating the vast movement of the stars into measurable physical space. Standardizing these massive builds required a universal ruler, leading humans to measure the world in units based on the body. They used the width of fingers, the span of their hands, and the length of a pace. This mammoth bone hut demonstrates an intuitive grasp of the circle, which encloses the most space while evenly distributing physical stress against the wind. This reflects a deep understanding of proportionality and applied physics, thousands of years before the first formal equations. Drafting a flawless, massive circle on the ground presented a challenge for ancient builders working without modern surveying tools. They used a cord and peg. Anchoring one end to a center stake and keeping the line taut, a person walks a full circuit to trace a perfect boundary. This guaranteed every point was equidistant from the center, defining the radius and diameter. The cord and peg physically constrained the builder's path, leading them to encounter the mathematical laws of equidistance. In the physics of hunting, a spearhead must be shaped into a sharp point, narrow enough to penetrate, but wide enough to remain durable. To hit a distant target, a hunter must calculate a curved parabola, throwing at an upward angle to account for the pull of gravity. The atlatl, or spear thrower, artificially extends the human arm. This creates a longer radius for the throwing arc, which increases the velocity of the projectile. Hunting required the human brain to process mass, leverage, and angular momentum in real time. Weaving functions as a binary logic system, interlacing fibers at 90-degree angles to create humanity's first geometric grids. Scaling a rectangular mat to twice its original length and width introduces a problem in estimating materials. Doubling the dimensions of a shape doesn't double the material needed, it squares it. This 4-to-1 ratio forced the mind to move past linear lines and conceptualize two-dimensional area. Prehistoric survival forced the human mind to unearth the geometric scaffolding that would eventually build the modern world.